Hey everyone, welcome to lesson 2.9. In this lesson, you're going to learn how to find the inverse of a matrix. This is important because instead of dividing two matrices, we are going to multiply by the inverse. This is the same thing as saying instead of dividing by 1/2, you can multiply by 2. And this works for any number. Instead of dividing by it, you can multiply by the inverse. And it works with matrices as well. This is important because we actually don't have a way to divide matrices, but we do have a way to multiply them. In fact, we already talked about it in lessons 2.2 and 2.3. And also, we're going to find the inverse of the one we want to move, so whichever one you're looking to get rid of. For instance, we're going to use them to solve equations that look like this. A matrix times x equals a matrix. X represents a matrix. It does not represent a number. If it represented a number, then this one would be the same size as this one. Since this is the one we want to get rid of because it's by x, we're going to multiply by the inverse of this matrix on both sides. Okay? Not all equations with matrices have to have an inverse. In fact, we're going to split up the notes on the bottom between equations that don't use an inverse and equations that do use an inverse. And the main difference is that these are using addition and subtraction, and over here it's using multiplication. And the only way to undo that multiplication is to multiply by the inverse. So here we have our standard matrix A, B, C, D, just like we started with in 2.8. The inverse of this has 3 pieces that you need to do. Out front, you need to multiply by 1 over the determinant. So if the determinant is 2, you're going to multiply by 1/2. Okay? This is not allowed to be 0 because you can't divide by 0 in math. That's not possible. So if the determinant is 0, it doesn't have an inverse, and you just stop there. Okay? Then what you multiply this by is a new matrix that is A and D switch, and B and C become negatives. So these flip signs and these flip spots. Okay? A and D swap. B and C flip signs. And then this is the inverse. The way we write or notate the inverse is with this little -1 up here in the corner. Okay, that means inverse. This is the original. This is the inverse. So let's take this matrix 4, 5, 2, 3. First of all, the determinant of A is where you subtract this, multiply this diagonal, which is 12, minus this diagonal, which is 10. And 12 minus 10 is 2. So we're going to have 1/2 times, and then we have to do these two things. So the 3 and the 4 are the ones that are going to flip spots, and the 2 and the 5 flip signs, like that. And then you're actually going to multiply that 1/2, which gives you 3/2, -5/2, -1, and 2. So we are going to get some fractions because it's not possible for all of them to work out. Then we're going to move on to matrix B. And the determinant of B is going to be 2 times -13, so -26. And -5 times 5 is -25. Don't forget you are subtracting. Since you are subtracting a negative, this turns into +25, which is -1. So you have 1 over -1. That's the same thing as -1. So I'm going to go ahead and switch that. And then the -13 and the 2 switch spots. And these two switch signs, which almost looks like they switch spots. And then we have to multiply all this by a negative. So our inverse, B inverse, ends up being 13, 5, -5, -2. Okay, and I'll go ahead and write that this was A inverse. So if I multiplied these two together, we would get what's called the identity matrix, where it ends up being 1, 0, 0, 1. Same thing over here. That's one way that you can check. Okay, let's talk about how to actually use this to solve. I'm going to start over here with when you actually need to solve with the inverse. So this is the one you want to get rid of, so this is the one you need to find the inverse of. Okay, so first of all, the determinant is going to be 10 minus 3 times 3, 9, which is 1. That's easy. And then the 2 and the 5 switch spots, and then the 3's both become negative. So I'm just going to kind of cross out this one out front because it doesn't really do anything. This is the inverse. And this is what we need to multiply by. Right? Here's the only tricky part about this, though. We're going to multiply by it over here on the left side of this matrix. That means you have to also do it on the left side of this one. So I'm going to cross this out really quick and write the inverse matrix with this one on the right side. So if you put the inverse on the left here, you have to put the inverse on the left here. Then I'm going to multiply these together. So first I'm going to double check over here. 10 plus negative 9 is 1. 6 minus 6 is 0. Negative 15 plus 15 is 0. And negative 9 plus 10 is 1. And that should always happen. This is the matrix equivalent of having a coefficient of 1. Okay, it's not going to change anything about x. It pretty much might as well not be there. Then over here, 2 times 4 is 8. Negative 3 times 3 is negative 9. 8 plus negative 9 is negative 1. And then on the bottom row, negative 3 times 4 is negative 12. 5 times 3 is 15. And negative 12 plus 15 is positive 3. So really, x is negative 1, 3. I can also check my answer by multiplying these two together again, and I should get 4, 3. Let's do the other inverse one, and then I'll show you how to do the ones that don't require inverses. This one is a little bit bigger because there's not a 2 by 1 over here. This is a 2 by 2. This is the one you want to get rid of because it's next to C, so this is the one we're going to do the inverse of. The determinant is negative 6 minus 0. So just negative 6. Now we're going to get some fractions. We're going to do 1 over negative 6 times the matrix, where I flip these two, and then these two would become negative. Negative 0 isn't a thing, so it's just 0, and negative 5. Okay, and then I'm going to give you a little bit of a hint. Now that you've seen that this is going to happen on the left side, we don't need to do that. We're going to multiply this by this. And my suggestion is keep the negative 1/6 out front, and then multiply everything and multiply at the very end. Otherwise, you're going to get some weird fractions. So I basically need to take this and multiply by whatever was on the other side. Like this. Okay, and we're just going to leave that negative 1/6 hanging out there for a second. Okay, so here we're going to have negative 24 plus 0. And then here we're going to have negative 2 times negative 21, so 42 plus 0. Okay, and then we're going to do this row times this column, and I apologize for not having circled this before. Negative 5 times 12 is negative 60, plus 3 times 24 is 72. Negative 60 plus 72 is 12. And then we have positive 105 plus 75. 105 plus 75 is 180. And then we multiply all of these by negative 1/6. 1/6 of 24 is 4, and the two negatives will cancel out. 1/6 of 42 is 7, with a negative. 1/6 of 12 is 2, with a negative. And 1/6 of 80, well, 1/6 of 18 is 3, add the 0, 30, with a negative. So the only one where the negatives canceled out was these two, because those two negatives made a positive. And this is C. So basically, you just take the inverse times whatever matrix is over here, but the inverse has to go on the left. Up here, I just did it like this to show you why. Down here, you can just kind of skip to that now that we've seen why. Okay, now, over here, here's the easy part. I am going to, so I want to get x all by itself, right? I need to get rid of this. So what I'm going to do is I'm going to subtract it to the other side. Okay, and what that's going to do is cross it off over here. So then I get negative x equals 5 minus 12 is negative 7. 3 minus negative 2 becomes 3 plus 2. 5. Negative 9 minus negative 5 becomes negative 9 plus 5. 10 minus 6 is 4. And then what you'll notice is x isn't all by itself. It's got that negative. You can still multiply both sides by a negative 1. So that then it's x instead of negative x. And everything just changes signs. And then on this one, it's a little bit easier to see, but there is addition. So we're going to subtract that matrix to the other side. The same way you would if you were solving an equation like 2x plus 3. You would subtract the 3 to the other side. You just have to do it with a whole matrix. Okay, and then we get 2x equals 5 minus 11 is negative 6. Negative 6 minus 4 is negative 10. 7 minus 3 is 4. And 13 minus 7 is 6. We want x, not 2x. So how do we get rid of that 2 out front? We divide it. So basically we're going to divide by 2 and divide everything over here by 2. Or it's the same thing as multiplying by 1/2. So that's going to leave us with negative 3, negative 5, 2, 3. So you can do the same types of things with matrices that you can do in regular equations, except dividing by a whole matrix.